the first thing we do? We find derivatives. I like that. Find derivatives. So we know f of x is equal to ln of 1 minus x. So what does f prime of x equal? What is it? 1 over 1 minus x times? So it's going to be negative 1 minus x to the what? To the negative first. Nice. So what's f double prime of x going to be? Negative 1 minus x to the negative 2. Yeah, because you drop a negative and kick a negative out, so it stays the same sign. Yeah. So then f triple prime is going to be negative times 1 minus x to the negative 3. That's kind of nice. Oh, then there's a negative 2. Thank you. Yes, negative 2. Thank you. Excuse me. Ooh, that was almost a catastrophic failure right there. X, so then you end up with negative 2 times... I know, I'm putting in all the numbers here like this. I'm just putting it in like this so we can see the pattern like that. Like that. So then what do you put next to all these numbers right here? F of 0 is 0, right? F prime of 0 is what? Negative 1. F double prime of 0, what's that? Negative 1. So what are all of these? I think they're all negative 1, right? Oh, I bail too early, don't I? Wow. Okay, I'm shaking it off. It's Blue Saturday. I'm doing my best here. So what's up here? Negative 6? Yeah. Nice. Okay. Okay. So what do we need to come up with if we're going to find this interval? The what term? The nth term, right? Like could we list out the Taylor polynomial now? The first few terms? Could we list out the first few terms? Yeah. Let's list out the first few terms just for fun here. So it's going to be f of 0, which is 0, plus f prime of 0 over 1 factorial x to the first. So what's f prime of 1? Negative 1 over times x, right? Plus f double prime of, not x, f double prime of 0 over 2 factorial x squared. What's that going to be? Minus what? X squared. And then let's just do the next one here. It's going to be minus what? 2 over 3 factorial. Is that correct? Yeah. Times what? Then what? Minus. Then what? Is that correct? Are we doing okay so far? Is that good? Okay. So what's the general term going to be? This one, as n goes to infinity. What happens to this right here? What does that go to? 1. That goes to 1, right? So what do you end up with? You end up with the limit as n goes to infinity of x to the n plus 1. I'm just going to drop it over x to the n. Negatives cancel and it's positive. Excitement. So what are you left with? Just x, right? So therefore, you know the absolute value of x has to be what? Less than 1, so x is between 1 and negative 1. So then what do you have to do at this point, though? Plug in the endpoint. Check endpoints. And how do you check the endpoints? You plug it into the, which one? The original, right? Yeah. Well, there's one in particular that you can not, that you know is not going to work immediately. Which one? These are x values, right? So like look at the original function, ln of 1 minus x. What can't you plug into that? 1. Why not? Because we can't take the ln of 0. So it's not in the domain, right? It's undefined there. So you know it's, so like 1 don't work since ln of 0 does not exist. Like that. So then what else do you have to check? Negative 1. And does it work? Oh, is it just asking for the radius? Yeah. Oh, it is? Okay. Well, let's just, so yeah, the radius is 1 in this case. That's nice. So let's go a little bit further. Let's just check that negative 1. How do we go about checking negative 1? What do we do? What should we do? If we wanted to check, it's kind of cool. Okay. Negative 1, sorry. I meant negative, yes. Negative. Excuse me, yes. Or key core Taylor series expansions with a number plugged in for x. Sine. This is sine. You should see the odd numbers right there. That is sine of x, where x is equal to what? This is sine x, where x is equal to what? What got plugged in for x? What is sine? Just tell me what sine is. What is the expansion for sine? You should know this. What is it? X. What? Plus the 7th over 7 factorial, right? Correct?
Yep.
So what number do you have to plug in for x here so that you get that?
1.
Yeah, it's just sine of 1. Done. This is sine of 1. That's all you're trying to recognize. E to the x is what? 1 plus what? What is it? What is it?
X.
Yep, plus. Plus 3 factorial plus 4 factorial, right? So what's e to the negative x squared going to be equal to? 1 plus? 1 plus? Negative x squared plus negative x squared squared over 2 factorial plus negative x squared to the 3rd over 3 factorial plus negative x squared to the 4th over what? It's literally direct substitution. That's it. What did we do? We took the negative x squared and where did we plug it in? All the places x was. All the places. Are we okay with that? Are we okay with direct substitution? Another way to say it is you can write out, e to the y is that. Doesn't matter what we call the variable. And then what do we literally do? We just let y equal what? Anything. We make y is equal to negative x squared. You can plug it in. Yay, exciting. Very fun. Substitution, relatively straightforward. Okay, what about this one right here? Does that look like something we know already?
Yes.
What is 1 over 1 minus y equal to? You know this, we did it yesterday. What is it, Teme?
1 plus y is y squared.
Yeah. It's the geometric series. We know this, right? So what does 1 over 1 minus x squared equal? 1 plus?
X squared.
Plus x to the 4th plus x to the 6th plus x to the 8th. Nice. Hey, done. Fantastic. So we recognize this as being super close to something we already knew the expansion for, and we plugged it in. Yes?
But that's 1 plus x. Aren't you 1 minus negative?
Oh, sorry. Minus. Sorry. Excuse me. Excuse me. Excuse me. So what is it going to be?
Minus x squared.
Minus x squared. Then plus what? Minus, let's just x squared squared. So what is this a good example of? Be careful with your substitution. Is that better? What did we do? We knew what 1 minus, so 1 plus is the same thing as 1 plus 1 minus what? 1 minus negative x squared, like that? Sorry about that. Are we okay with that, right? So where do you plug this in? You can just take this now if you wanted to. You could take this right there and plug it in right there. So you end up with 1 over 1 minus 2x minus x squared is equal to 1 plus 2x minus x squared plus 2x minus x squared squared, so forth. Like that? Absolutely. Now what's the other thing you could do? If you have this and you want to turn it into that right there, what could you do to both sides? You could square both sides, or you can multiply both sides by 1 minus x. What's nice about this is you kind of get the ascending powers a little more cleanly. You don't have to multiply a whole bunch of things out. Either way, you don't get like the nicest looking thing, but either way is fine. I like that.
What's the second way?
The second way would be this. Look, so you know that this is true, right? So what you can do with this is you can multiply both sides by 1 over, you could square both sides effectively. Like if you square this side, what do you get? 1 over 1 minus y squared. So you just put a parentheses around this thing and go squared.
Okay.
Which you can do, but I like this. This is kind of cool.
Wait, so can you do it the other way?
It would literally be like this. 1 over 1 minus y squared equals. Done. You can do that, but Tami's is cooler. Okay. Find the Taylor series for x equals 0 for arctan from the series 1 over 1 plus x squared. Oh, what the heck? Oh, wait. Step down. Don't be too excited. Don't be too excited here. Jesse, what is the expansion for 1 over 1 plus x squared? Well, we know that was 1 minus negative x squared. We did that before, right? So what's it going to be? It's going to be 1 plus negative x squared plus negative x squared squared plus cubed and so forth, right? Are we okay with that? Okay, that's exciting. We have that out. So what do we have here? We have 1 minus x squared plus x to the 4th minus what? X to the 6th. It alternates. Are we okay so far? What is this asking us now? It says find the Taylor series for arctan. What is arctan? Tan inverse, right? What's the relationship between tan inverse and that? Give me a complete sentence. 1 over 1 plus x squared is the what? Derivative, right? Is the derivative of that. Okay, very nice. So if we want it, so we now know that 1 over 1 plus x squared is equal to that. If we want to turn this into tan inverse, what do we have to do to both sides? Integrate. So what do we have to do on the right? Integrate. So integrate that for me. What is it going to be? X, yep. Minus
1/3 x
cubed over 3, yep, plus
1/5
x to the 5th minus what?
x to the 7th
Over what?
7.
Goes like that, correct? Now what does it say to do in this problem? It says find the Taylor series for x equals 0. Oh, did we find it? We done? What do we think? The tangent of pi over 4 is 1, correct? Are you okay with that? What does that mean the tan inverse of 1 is? Pi over 4. So what do you multiply both sides by? Therefore, 4 tan inverse of 1 is what? Pi. 4 tan inverse of 1 is pi. So what do we know tan inverse is equal to? This thing, right? So what should we do? And plug in 1. So what do? We make it 4 tan inverse of 1 is going to be equal to 4, and then what do you plug in here? 1. So you get 1 minus a 3rd plus a 5th minus a 7th plus a 9th, like this. That's pretty freaking cool. So what's that equal to? Pi. That's pi.
What happens with C?
Oh, what happens to C? It's a good question. What happens to C?
Go on.
What happens to C?